Continuous Integration Review with Jeffrey Palermo. Hey, that's me.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast, deliver quality, and run your software with confidence in Azure, all while using everything the .NET ecosystem has to offer. And I'm doing tons of online user group speaking, continue to do that. And if you run a .NET or Azure-related user group, I'd love to give a presentation for you. And our sponsor, ClearMeasure, makes this podcast happen. We are a software architecture company that empowers .NET teams to be self-sufficient and able to deliver world-class results. So if we can help, please get in touch. And if you are a .NET software engineer who wants a path to become an architect, we are hiring. I'd love to work with you. Just go to clearmeasure.com/careers. And also be sure to check out the new video show, Architect Tips. Now, today we don't have a guest. We've had amazing guests. So if you are just discovering the podcast, make sure to look at past episodes. My attempt is to produce a timeless podcast. So besides major platform shifts, I try to limit the amount of current events I cover. Instead, I want you to gain knowledge and insights that really transcend whether you're on .NET 4.8, .NET 5, .NET 6, etc. And this is also, one of those podcasts where we're not even going to mention any kind of language or library. Today, I want to talk about continuous integration. And with the ease of setting up triggered builds on build servers like Azure Pipelines or GitHub Actions, it can be easy sometimes to think that once the documentation of the product is followed, that we're done. But that's not the case. The DevOps tools that are out there in the market, they've gotten really good at making some of the steps easy, but there's other steps where it's still up to you to put them in place. So today, I wanted to give you an overview of continuous integration, the three major parts to it, and some of the rules of thumb that you need to follow so that you can fall into the pit of success. Now, we all want to move fast. We all want to deliver consistent quality, and we all want to run our software in production with confidence, knowing that everything works and we won't be surprised by bugs getting through. Now, at this point, if you haven't listened to episode 150 with Capers Jones, I highly encourage you to do so. Capers is probably the most prolific publisher of research on the software industry, and his research shows that quality precedes productivity. If you want your team to go fast and you focus on just going fast, your quality is going to suffer. And then you won't go fast at all because you're drowning in quality problems. It's an interesting dynamic. In an attempt to move fast, you may skip some automated test cases or push something out without fully thinking through all the aspects of the design. And then when a production bug happens, a developer stops working on a feature and spends time fixing the bug. And in this instance, we discovered new work that had to instantly move to the top of the priority list, pushing back prioritized feature work. And it's very likely that that developer, they're going to lose half a day or maybe more fixing the bug. And then there's more pressure to finish the features that were already on the docket. And of course, if that new feature doesn't have a complete design or a complete level of test coverage, then a bug in it's going to surface soon. And it's going to repeat the cycle all over again. And then on aggregate, across the team, the discovery of bugs and the effort to fix them can end up consuming a lot of development time. Now, from outside the team, others may look at the development team and say, development doesn't move very fast. But in reality, development of the new features that people are waiting on moves just fast enough. But because of the quality issues, the leftover development capacity in any given week, compared to the actual work on new features versus bugs, it's not full-time effort that we're giving to the new development. It could be a fraction of a development week. And the point of which all of this is we have to keep it under control because there is a point at which all development time in a week is used to fixing existing defects. And this is when we hit development bankruptcy. So some people call this dynamic technical debt. And it's called this to invoke the metaphor of interest payments on a credit card. If my paycheck per month is $4,000 a month, and I pay $100 per month to pay the interest that's accrued on the amount that I've charged on the credit card, then I can keep going because I have $3,900 left of available cash for rent and other expenses. But if I continue spending above my means and continue charging up credit cards, then there will come a time when I'm paying literally all of my money just to pay interest. And at this point, I've fallen over a financial cliff. My margin for adjusting and recovering is completely gone. Same thing happens in development. Well, technical debt in software is incomplete design or insufficient test coverage. I paid for a feature, but I only paid for some of it. The rest of it, I put on the charge account to be paid in the future when the bugs are found because of what I didn't finish. In the future, when the bug surfaces, because of that incomplete design, I'll have to pay down that debt. When a bug slips through because no test was covering that path of behavior, then I'll have to pay down that debt. Payment, in this case, is all in the form of time. And anyone who's been doing development for some time has experienced situations where they had their week all planned out nicely. Feature A would ship on Tuesday, feature B would ship on Friday, and then in comes a bug. Surprise! And now your schedule's completely host. You can try to explain why feature A or B didn't make it in time, but what are you going to say? Some gremlin got into the code and broke something? It's not my fault. Well, when it comes down to it, the only truthful thing to say is that a previous design was incomplete, or I didn't have all behavioral paths covered with tests to prove them. But either way, you customer, I told you that a feature was complete last week or a few weeks back, and now that you can see that the feature actually wasn't complete. And now I have to finish the work that I had previously reported as finished. So let's talk about continuous integration. When continuous integration is actually followed, it shines a bright light on this dynamic, and it helps us complete the work as we move through, and so that overall we stick to our budget of development time and fully pay for the features that we ship. So Capers-Jones's research confirms that teams that achieve high quality also achieve high productivity as a byproduct, but teams that don't achieve high quality are continually mired with low productivity. So let's go over the key areas of continuous integration so that whether with Azure Pipelines or any other tool, you can make sure that you've put everything in place that you need to. So there are 3 overall stages of continuous integration. I'll go over each of them one at a time. The first stage is the private build. The second stage is the integration build. And the third stage is the first deployment. And I'm not going to talk about continuous delivery or automated deployments or deploying from environment to environment to environment. We're just talking about continuous integration as a practice. And there was a book written on continuous integration in 2006. That's a long time ago, 15 years. So if you haven't read that book, then go back and read that book because, in 2009, there was a book on continuous delivery that came out from the same publishers, Addison Wesley, and it kind of referenced the previous work of continuous integration. Either one of those books, you'll get a good overview of continuous integration. But if you haven't read that book from 2006, literally titled Continuous Integration, then go and read that text and train up your team on that practice. But let's go over the first stage, the private build. The private build happens on a developer's workstation, and it's literally what it is. It's a build that's private to a single developer. This is the build script that every developer should run locally just to answer the question, hey, I've changed some things. Is the code that I have on my feature branch, is it stable and ready to be committed and pushed into the version control system or not? Or did I just break something? And yes, it is a script. In today's .NET development environment, it's going to be a PowerShell script. And you could use, a build script framework, but you know what? Vanilla PowerShell script works just fine. And I published over time private build templates that work for any number of project types. So if you can't find it, just send me an email and be happy to point you to literally my private build script. And it's pretty easy to put together. But at a minimum, the private build script is going to set up a local developer environment. So if there's a chocolatey package that needs to be installed for a particular code base, it checks to see if it's installed, and if not, it installs the package. If there is, if SQL local DB needs to be started up, it starts it up. Any environmental initialization or environmental setup for that particular code base to operate, it's set up in the private build script. Very common is a SQL Server database schema needs to be created, and the migration scripts are specified in the source code. So even if you clone it for the first time and run the private build script, well, then your migration tool is going to run, and boom, you're going to have the proper SQL Server database locally. Or if there's some data structures that need to be created locally, it creates it. Once environmental setup is done, then we compile the code. And that's running MS Build or running .NET.exe. It's compiling the code. Then the next thing we need to do is do some steps of validations. And at a minimum, you want to have at least your level 0 and level 1 test suites running in the private build script. And level 0 is your unit tests. Those are tests that don't have any code path calling out of memory, so they're super fast. Your level 1 tests are integration tests, and the most common form is tests that go from application code over to a SQL Server database. Make sure your data access code, your queries are running, and anything else that might call out of process to something else on your computer. We'll get to level 2 tests later, but those are more like full system tests.
Many thanks to our podcast sponsor, ClearMeasure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast, delivering quality, and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, ClearMeasure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. ClearMeasure, empowering software delivery.
So that's your private build script, and it's pretty simple. We want to set up the local workstation, we want to do a compilation, run our unit tests, run our component level integration tests, and if we have been following test-driven development and we have test coverage accumulating as the production code accumulates, then we'll have a high level of confidence that the stuff that used to work continues to work, and the new stuff that we just built also works. And you'll know that you can commit and push your branch and then go on. So that's the private build phase, and it happens on a local developer workstation. The integration build is the next phase, and that has that operates on a team shared build server, and it operates on all of the various branches you have on source control. And so obviously it's gonna happen on your master branch, and every time anything is merged into your master branch, the integration build needs to run. And the integration build at its heart runs the private build script. So all of the same sequence of steps that the private build script runs, it runs in the integration build. It's just that it's running on a shared build server. Now, if you're in Azure Pipelines, then you're in the hosted builds, or you're running your own. And so the local SQL Server database is going to get spun up. Any kind of other environmental things that you need are going to get created. Then we're going to compile the code. Then we're going to run the unit test. Then we're going to run the component level integration tests. And then you'll have some other quality control checks that you'll add that you as a team have decided that you want. Like static code analysis is one that every team should have in the integration build. And there's static code analyzers for literally every language on the planet. And great, freeware. There's great commercial products like Sonar from Sonar Source. SonarQube is really good for .NET code. So that's your integration build. And whenever you whenever you run your private build and commit and push code to a branch, you want to have your integration build configured to run on all branches so that you have the benefit of the integration build running on your feature branch even before you've submitted your pull request, so that you know it happens. And then, of course, after you your pull request accepted, the merge will happen on the master branch and the integration build will kick off again. So that's the second stage in continuous integration. And that answers the question at the team level. With the changes that developer A made and developer B made, and the feature branches coming together with all the various code that's been merged, that combination, do we still have a stable code base, or did something break? And of course, if we still have a stable code base, then we can go on to the next phase, which is the first deployment. And this is where some of the tooling focuses just on a automatically triggered build and erroneously calls that continuous integration. That is the second stage of continuous integration, but it is not all of continuous integration. And so the first deployment is the third piece that we need, and that answers the question, does this build still deploy properly to its appropriate environment? Do all of the application components still start up properly, or is there a configuration problem somewhere? And does the application still function like it used to, or did something break? So those questions can only be answered by actually deploying the application somewhere and starting it up and running it through its paces. So we have three concepts in order to make that happen. One is we have release candidate packaging, which the integration build needs to do at the end of a successful build. We need to package it up for release. Now, this is going to be packaging it up as NuGet packages, which is the packaging mechanism for .NET programs. And then we need a mechanism to do a complete deployment. The integration build and running of unit tests and integration tests, that just kind of runs it locally on a single computer. That's not actually installing it in the appropriate environment. And of course, with Azure, installing it means, yes, putting those web applications in app service, putting the worker jobs, the worker services, putting those in your app service hosting plan. Or if you have something running in Azure Functions, or if you have some data in blob storage, or if you need to spin up your Azure SQL database, absolutely, you need to create or have an environment there to actually install the pieces and then start them up, make sure that they actually start up properly and that you didn't accidentally break the configuration only to find out later when you do a deployment. And then we need to run it through its paces. This is where the third test suite comes in. This is our level 2 tests. This is our level 2 tests, which are full system tests. Some people like to call them acceptance tests. Some people like to call them through the UI tests because they're through the user interface. Doesn't matter what you call them. They're exercising the fully deployed application deployed in a representative environment. And yeah, if your application has a user interface, of course, you're pulling up a browser or the UI and you're actually pressing on buttons and typing in text boxes. But for the batch jobs or worker services that are running under the covers, you're triggering them in whatever mechanism they need to be triggered, whether a message drops in a queue, you are running all the various types of transactions that your application supports to make sure that something didn't just break. So that's the third phase and the third question. And then once that happens and your full system test suite passes and all that runs, well, you know that you're good for deploying that version of the software to any other environment because all the things that used to be working continue to work. So let's quickly review the three phases of continuous integration. The first one is the private build. That runs on a developer workstation, and that answers the question, did what I just changed break something, or do I still have a stable code base that I can share with my team? That's the first phase, because you don't want to waste your team's time. The second phase is the integration build, and that answers the question, does the code, now a mix of multiple changes from multiple developers, do I still have a stable code base now, or did something break when putting the two good branches together? And then the third phase, the first deployment, answers the question, did this release candidate deploy, start up, and continue to function properly, or do I have a unstable release candidate version? All three of those questions are important questions to answer. And if you don't give yourself an automated continuous integration process, then you're going to be answering those questions using manual tasks, manual testing, manual verification. So I wanted to go over continuous integration. If you see in some of the text, the word commit phase, that is the same as the private build phase, where you're deciding whether it makes sense to commit your changes or whether you're unstable and you still need to keep working. So I hope that helps. I want every single one of you to be able to move fast and deliver consistent quality and run your software systems with confidence. And continuous integration is a required practice in order to do so in any kind of team development environment. And so I hope that helps. And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.